Hi, my name is Kelly Lewis. I am in Group 5 and I am responsible for the visual arts section of our unit plan. We chose conservation as our unit for science and math and visual arts. It spans over, there's a lot of overlap, and it's an issue that a lot of kids are really interested in. It's nice to give kids a little bit more peripheral outside of what is right in front of them most of the time, and kind of expand their world a little bit and give them a chance to have a voice. So that's kind of what the visual arts component of it is really looking at, is giving kids a voice through art to address some of the issues that we see in conservation. So for my SOLs, we are looking at 8th grade, and the wonderful thing about visual arts standards at any level is they're very broad. So there are a couple that are really specific about 1 and 2 point perspective, but otherwise they're basically falling under 4 different umbrellas, and those are creating, presenting, responding, and connecting. So how kids create art, getting them to present their artwork, responding to other artwork, and connecting all of those together. So the 2 SOLs that I'm really focusing on that you see in the curriculum map are 815 for Virginia, which is the student will analyze how visual organization in works of art affects the communication of ideas. So as we look at conservation in artists, we're going to see how they communicate their ideas through artwork. And then the next one, 816, the student will analyze the uses and impact of persuasive techniques in print and contemporary media. So how we can be persuasive with our artwork, this also goes into other kinds of things like advertising, things kids are seeing every day. But within this unit, we're going to look specifically at how we can be persuasive with ideas that we're passionate about and how to communicate those with other people. So this connects really closely with science, which is going to be doing ecosystems, watersheds, all that kind of stuff. The 3 artists that we're going to be looking at on the first day are Robert Weiland, more commonly known just as Weiland. He is a California artist who is passionate about marine life, specifically whales. These are one of his whaling walls that has a double entendre there. You can see the scale that he paints at. It's just absolutely ginormous. He wants to bring these animals up and close with people at a scale that really represents how huge they are, and is a point of conversation for a lot of people. The whaling industry has been an issue for decades, continues to be an issue, and it's an issue that he's passionate about. So what he does is he really brings these animals into people's worlds. That's his form of persuasion, is kind of getting them to feel the magic of these humongous creatures. He paints beautiful reefs and just gives people a chance to experience things that they normally wouldn't be able to see in order to be persuasive in conservation of whales and marine life. Andy Goldsworthy is a UK-based artist. He is really interesting because a lot of his artwork is really temporary. This is actually a still from the video we're going to watch the first day called Rivers and Tides, and he makes this beautiful structure, but as a tide comes in, it lifts it up and then carries it away. And that's a really interesting point for a lot of students. The impermanence of his artwork is really alluring. We don't see a lot of his artwork unless he takes a picture or videos it, because nature just takes it back. He doesn't make an impact with what he creates. He uses all natural materials and lets nature have him back when he's done, which is really interesting. The last artist we're going to look at is Ansel Adams. Ansel Adams took photographs of a lot of the West before people really got to go out there and put their mark on it, before it really got overdeveloped. And he was also instrumental in working with Teddy Roosevelt on establishing some of the first national parks. So that's pretty cool too. He shows us what a lot of these really special places looked like before people came in and entered the scene and started to shift what it looks like. So there's a very strong connection to science with all of these, with environments, with ecosystems, with the influence that humans can have on these. And then persuasive argument for the visual art SOLs comes in. This is a great place to kind of get kids passionate about things outside of their world that they can hold on their hands. The world's bigger than that, and it gives them a chance to get excited about some of that and make their voice heard. As far as its connection to math, it also does a wonderful job. Kids are going to be doing some self-study on different environmental issues, and that's going to have a lot to deal with percentages, with probabilities and statistics and all of that. So kids are going to be able to bring math into the art classroom, science into the art classroom, and then take it right back out with them into those classrooms as well. So the next person who will be talking is Braden, who is in charge of the math section. Thank you.
Thanks, Kelly. As she said, my name is Braden Bevins. I will be doing the mathematics part of our interdisciplinary unit plan. We chose conservation, and again, it was the 8th grade. The VOLs that apply to math in this scenario are the 812 and 813 VOLs for Virginia. They pertain to box plots and scatter plots. So mainly it's a section of probabilities and statistics, like Kelly had indicated. I felt this was a good choice for mathematics when it pertains to conservation because of the ability to use statistics to indicate trends and patterns and different things. In this situation, specifically related to a lot of weather patterns that have been changing over the course of time because of issues with conservation regarding energy use or lack of conservation for energy use, especially fossil fuels. The class will start off with discussion about what's been learned in other classes, specifically the different sections they've been coming from. I know kids like to share information they're learning between different classrooms, which is really great. Try to keep the interest up as we go along. For the box plots, I have a nice paper here as far as weather patterns go. It's actually got a pattern of different cities in the U.S., a particular city in the U.S., and cities around the world. My plan for the box plots is to have them complete that chart one day in a group activity. The next day, I was going to have them complete it with historical data. So use weather.com to research the first section, complete the 3 different sheets for weather patterns currently being experienced, then the historical data, and utilize the 2 different sets of data to compare and make analyses to different changes that we've experienced in weather patterns in both the United States and worldwide. The big function of the box plots is to be able to not only create a box plot, but infer data and observations from that information. So that's why I chose that activity. At the end of that week, there'll be an assessment over box plots, creations, and so forth, with a review happening beforehand. The second week will follow with scatter plots. Scatter plots, again, will be used to decipher a lot of information regarding conservation. Again, I want to discuss how things are going in other classes, what they're learning, what things are interesting to them. Try to keep their activity and their engagement really up and see what types of topics are exciting to the students and see if we can expand on those throughout the course. The scatter plots will utilize a couple of various worksheets, again, relating to weather. One is a snowfall indicator for northern Michigan. It tracks historical snowfall amounts. You can create the scatter plot, draw a best fit line through it, make inferences and observations as far as that information goes. I was going to have that happen as an activity to, again, engage them in not only mathematics, but to understand and see the changes that have been happening historically and the effect that those changes have, or the causes that those changes have had or occurred for, through the lens of mathematics. Be able to see numerically how math can apply and math can be used to understand these types of issues in conservation and the results or needs for these things in conservation. That chapter or that week will end with another assessment. Will actually contain 3 sections, including 811, which is about probabilities, with a test. They will have a review the day before, and we'll have a quick review, question and answer beforehand, before I administer the test. But through all in all, everything trying to relate back to conservation, how conservation can make a difference on various different things throughout the world, and the different lenses you can use to look at those efforts or those effects of conservation. The next class up, or next content up, is going to be Kathleen with science, and I will pass it off to her.
Thanks, Braden, for the introduction. I'm Kathy Klein. I am teaching the science part of our collaborative unit. My class is going to focus on abiotic, biotic factors, watersheds, ecosystems around the watersheds, pollutants, and the effects from the pollutants. So the students will actually be able to identify what abiotic and biotic factors are. They will be able to understand how the watersheds work and how all the water systems are intertwined, especially starting, with the rivers that have the runoffs that connect to the bays, which connect to the oceans, and how they all kind of intertwine together. And so they can actually see that, a trash dump site up on a mountain can actually affect a far greater area than just that one spot. They'll also look into how the ecosystems play a role in the watershed systems and how the systems are affected by pollutants, whether they're point or non-point. So, point being it's normally toxic. You can pinpoint exactly where it's coming from, and it has a really bad effect. A non-point pollution is actually just like a simple runoff, where they're not quite sure where the pollution is coming from. They can't have a pinpoint, and it's normally not toxic. Rainwater washing off the mountain. They can't pinpoint where it's coming from, but it's not toxic either. So they'll actually start doing that. Some of the activities we'll do is students will actually build their own watershed system in like a Tupperware box. And they'll have clay and sand and water and little animals and trees to put in there, some soil, different types of soil, different types of sand to see which soils and which sands hold water best. And they'll kind of work with a group and decide what kind of watershed and ecosystem they want. And then they'll actually add a pollutant, whether it's a non-point or a point, and see how it affects the rest of their watershed system. Another couple of things we'll be doing, just simple worksheets, like, putting the abiotic, biotic sections in. We have the importance of watersheds, so it's just kind of going over main vocabulary points of what needs to be done. This one's going to be, list 10 different examples of pollution and label if they're non-point or point pollution. So it's kind of letting them think for themselves, build an understanding, and they can make a connection to the community based on, whatever they choose. So if they want to look at, for example, I live in the mountains of West Virginia, they can look at the runoffs and say that that's a non-point. And they can also look at the mines that we have around here and say that that's a point, where it gets into our water system. And then another cool one, we actually have this pollution game. So all of these will be printed out on a larger cards, and we'll stand in a circle, and it's like a fast-paced, hectic thing, and they have to either point with their elbow for a non-point or point with their finger for a point, and if they get it wrong, they're out. And it's fun and keeps them on their toes and helps them learn it a little bit. And then we'll just go over in general how watershed systems work and how pollution can affect it. Some of our SOLs or standards that go with this, it's all going to be earth science standards. So they'll be able to plan and conduct investigations. They will be able to demonstrate an understanding of the nature of science and the scientific reasoning and logic behind it. They'll be able to investigate and understand the difference between renewable and non-renewable. So we'll talk about fossil fuels, minerals, rocks, vegetation, things like that, and which ones are kind of found in Virginia. We'll also investigate how freshwater resources are influenced by other processes like human activities and, regular earth movements. We'll also understand that oceans are complex, interactive, and physical, and some long and short-term variations, and how the environment and humans have an impact on it. And the last one will investigate and understand the origin of evolution of the atmosphere. So we'll actually touch base on air pollutants as well, not just water, but we'll just be starting to dive into that. So that's the science part. This was a lot of fun to work on. It was really cool to see how we could tie our math and our art together. Math has the capability of doing all the mathematical, finding a population density and doing all those scatter plots and the box grids and things like that. And then tying in the renewable resources for art really helps solidify that the students can see the way it all connects. So look forward to seeing it in action. Thank you. Bye.